So today we're going to take a look at something that is referred to as the geometric mean. Now, before we get too involved in this, we need to figure out the difference between geometric means and arithmetic means. Now, an arithmetic mean is what you normally think of as your mean. It's a mean, it's a linear average of the data points that we have. Whereas a geometric mean, now you may remember a geometric sequence is a sequence that is following a exponential pattern, not a linear pattern. So today we're talking about geometric means and how to use them and what they mean and how they're helpful. Incidentally, geometric means do show up in math counts, once every couple years. So just throwing that out there. All right. So for theorem 8-11, now we're going to be taking a look today mostly at triangles to explain the geometric mean. And so I'm going to go ahead and I'm going to draw a right triangle here. And then I'm going to draw, a altitude here. We're going to pretend that's a straight line. And so I'm going to put some labels here. Let's say we have A, B, C. Let's call this X. Well, this triangle and this with the altitude is actually kind of a cool triangle because all three of these triangles are similar. So triangle AXC is similar to triangle CXB, which is similar to triangle ACB. Right, and that's all that theorem is. Now the geometric mean, on the other hand, well, that's actually going to help us solve some problems. So we're going to take the same triangle, do the reverse colors, and we're going to call this, again, let's call this A, X, B, because B comes after A and C. And so the first geometric mean has to do with line segment CX. Now I'm going to also call these side lengths, I'm going to name these side lengths, and you'll remember that side lengths are lowercase letters, whereas vertices, angles, are uppercase letters. So I'm going to call this A because it is opposite angle A. I'm going to call this B because it's opposite angle B. Now C, well, obviously C is broken into two parts, and we're going to call this, okay, so actually, you know what, let's call this D. All right, so let's call this X, and let's call this Y, and I'm going to call this H for the height of the triangle. And again, side lengths are all lowercase. So the first thing that I'm going to point out for a geometric mean is h squared. That is the length or the height of the triangle squared is going to be equal to x times y. So now there are two other relationships that we do need to talk about, where B, and it's kind of similar to the actual geometric mean in 8-1-2, B squared is going to be equal to x times, I believe it is C, yes, C. Well, if B squared is equal to x times C, then we also know that A squared is going to be equal to y times C. And those are some really kind of cool relationships that we have in a right triangle with an altitude that comes out of the vertex that is also right angle. Well, how does this come into play for math counts? Well, here we have a question in the bottom left corner that says find the fourth number of this geometric sequence. So we are going to use this rule right here, this geometric mean rule. And so in this case, we have h as the middle number, which would make this x, which would make this y. So using the rule of geometric means, we know that h squared is equal to x times y. Well, in this case, that means h squared is going to be equal to 40 times 10 So h squared is equal to 400. Take the square root, and so we get h is equal to 20. Well, that's absolutely wonderful until we realize we need the fourth term, and so then we have to do the same process again. 20 times 40 is going to be 800, and so we have the square root of 800. So we have the square root of 2 and the square root of 400, and so we end up with 20 root 2. All right, so then, so that's the basis of what you're working on today. You can find a definition for the geometric mean yourself. You don't need me to recite that to you. And go ahead and give the problems on the next page a try.